Hi everybody, this video is about finding the area of a regular polygon. First of all, what does regular mean? A polygon, actually let's do it from here. Polygon just means a shape with straight sides, and it has to be closed. Can't be open. It's got to be a closed figure with straight sides. It's a basic definition of a polygon. Regular means that all the sides are equal and all the angles on the inside, all the interior angles are equal as well. So a regular polygon has equal sides and equal angles. Sometimes we have special names for it. If it's a four-sided figure, a regular polygon would be a square, because that's a four-sided figure with four equal sides and four 90-degree angles, four equal angles. For a triangle, it's called equilateral, an equilateral triangle. All the sides are the same, and all three angles are 60. There aren't those special names for any number of sides on a polygon, so that's why the separate name for it. So if it's a pentagon, we could call it a regular pentagon, or a regular hexagon, or a regular octagon, nonagon, decagon, dodecagon, depending on how many sides there were. But regular means equal sides, equal angles. And the question here is, how do we find the area? Well, any of these regular polygons we can divide up into triangles. And in the case of a hexagon, which has 6 sides, there are 6 of those triangles. So if we can find the area of one of those triangles, we can multiply it by 6 and get the area of the whole hexagon. So for this one, again, so the area of a triangle is 1/2 times the base times the height, and we're going to multiply that by 6 because there are 6 of those triangles that make up the hexagon. Okay, so the height of the triangle we actually already know. It's 6√3, so I'm going to put that in there. Now the challenge is to find the base of the triangle. Now all of these, all the way around this point right here is 360 degrees. And we have 1, 2, 3, 4, 5, 6 of those angles that go around that point. So 360 divided by 6 is 60 degrees. That means each of these angles here is 60 degrees. And when that height is drawn, that dashed line in there is drawn, it cuts that 60-degree angle in half, so we've got 30 degrees. So what we've got here is a 30, 60, 90 right triangle. Now if you remember your 30, 60, 90 stuff, we take the long leg, you divide by √3 to get the short leg. So that side is 6. And just for the heck of it, you double that to find the hypotenuse. This side would be 12. We don't end up needing that, but just as a reminder of how the 30, 60, 90s work. Now, if this is 6, this is 6, and so the base of this whole triangle is 12. So that is the number that goes here. Now we've got everything we need. 1/2 times 12 times 6√3 gives us the area of one of those triangles. You multiply it by 6 because there are 6 triangles that make up the hexagon, and you've got your area. So let's do that. Let's see, half of 12 is 6, times 6 is 36, times another 6 is 216 √3. So that's an exact answer. If you wanted to write it as a decimal, you could. We just plug all that stuff in there. 216 times the square root of 3. And 374.1, if we round to the nearest tenth, which is about 374.1. And there is our area written as a decimal to the nearest tenth. Either one of these is fine here. Let's try another one. Okay, this one has 36 sides, called a regular 36gon. And I haven't drawn the whole thing here. Hopefully you gather that since there were 6 sides in this one, that there were 6 triangles that made up the shape. So since there's 36 sides here, there's going to be 36 triangles that make up this polygon. So when you find the area of the triangle, which is 1/2 base times height, you're going to multiply it by 36 instead of 6, because there's 36 of those triangles, 1 for each side. Okay, now here's the center, and all the way around that center is 360 degrees. Since there's 36 sides, there's 36 of these angles that go all the way around. So 360 divided by 36 is 10 degrees. So this angle right here is 10 degrees. Now, we're going to draw the height, because the area of a triangle is 1/2 base times height. That makes, since this is 10, each of these is 5. So our base right here, we can actually fill in the base right now. The base of that triangle is 10. We need to figure out the height. Now we just figured out this big angle here is 10 degrees. That means this is 5 degrees. Half of 10 is 5. Now this is not a special right triangle. There's no such thing as a 5, 85, 90 special right triangle. For the hexagon, we did get a 30, 60, 90, so we didn't have to do anything special there. But here we're going to have to use SOHCAHTOA to find the height of that triangle. Now, opposite the 5 degrees is this side, so that's the opposite. Well, I called that the height, but the hypotenuse is there, so that makes this the adjacent side. That's the one we're looking for. So opposite and adjacent means we use tangent. So we're going to say the tangent of 5 degrees, is 5 over h. Put that over 1. 5 times 1 is 5. H times the tangent of 5 degrees. So we divide both sides by tangent of 5, and we get 5 divided by tangent of 5 degrees, which we could get as a decimal. Let's see what that is as a decimal. 5 divided by tangent. Let me make sure I'm in the right mode. I am. Oops. 5 divided by tangent 5. 57.150 and some more decimal places. 57.150 and some more. Now that number is the one that goes, that goes in there. That is the height of that triangle. 150. Now, for the sake of accuracy, you should have all those digits in your calculator already. So keep them there and use them. That'll keep you from having to type them all in again, or from rounding and getting an answer that's not quite accurate. So we're going to take that, we're going to multiply it by 36, so times 36. We're going to multiply that by 10, times 10. And then times a half, or divide by 2, either one's fine, times 0.5. We'll hit enter, that'll give us our answer, 10,287.0 to the nearest tenth, which is about 10,287.0. Let's, for the heck of it, let's say these were in inches when we were talking, or in our original problem. That means our area units would be inches squared. And there is the area of our regular polygon. Hey, you still need some more help? Get it in class. Talk to you later. Bye.